Have you ever wondered where stars come from? A question as old as humanity itself. The birth of stars is a cosmic marvel, a process that begins in the seemingly empty expanses of space, within vast clouds of dust and gas known as nebulae. These nebulae are the cosmic nurseries of stars. Within them, gravitational forces begin to pull particles of dust and gas together. As they accumulate, they form a dense core, growing hotter and hotter as more material is drawn in. This process, known as gravitational collapse, continues until the core becomes so hot and pressurized that nuclear fusion ignites. This is the spark that brings a star to life, radiating light and heat into the universe. Just like that, from a simple cloud of dust and gas, a star is born. It's a cosmic dance of gravity and energy, playing out across the vast stage of the universe. So, the birth of a star is a cosmic event that begins with a simple cloud of dust and gas. So, a star is born, but what happens next? Imagine a tightrope walker, balancing with utmost precision. This is quite like the main sequence stage of a star's life, where it spends the majority of its existence. Picture our sun, a perfect example of a star in this stage. The star is in a constant struggle, a cosmic tug-of-war. On one side, we have the immense force of gravity, relentlessly pulling everything inward, trying to make the star compact. On the other side, we have the pressure from the fusion reactions happening at the core. These reactions, fusing hydrogen into helium, generate an outward push, resisting the crushing force of gravity. This delicate balance, this dance of forces, maintains the star's stability. The star shines brightly, pouring out energy into the cosmos, living its cosmic life in this equilibrium. And thus, a star lives out its longest life stage in a delicate balance of forces. All good things must come to an end, and stars are no exception. But how does a star die? Well, the answer is as fascinating as it is complex. When a star has used up all its nuclear fuel, it doesn't just flicker out. No, it goes through a series of dramatic transformations. Stars like our Sun, for instance, expand into what we call red giants. These are huge, luminescent bodies of gas and dust. But this grand phase doesn't last forever. After a while, these red giants start to shed their outer layers. Picture a celestial onion peeling away layer after layer. This process leaves behind a dense, hot core called a white dwarf. Now, white dwarfs are a bit like cosmic embers. They glow with residual heat, but they're not generating any new light or heat. Over billions of years, they'll slowly cool and dim, their once brilliant light fading to a mere glimmer. For stars like our Sun, their end is a quiet fade into the darkness. But what about the massive stars? Their end is anything but quiet. Picture this, a star, much larger than our Sun, reaching the end of its life. As it exhausts its nuclear fuel, the star's core collapses under its own gravity, triggering an immense explosion, a supernova. These stellar explosions are among the most energetic events in the universe, outshining entire galaxies for brief moments in time. But supernovae are more than just cosmic fireworks. They serve a crucial role in the grand scheme of life as we know it. You see, the intense heat and pressure of a supernova provide the perfect conditions to create heavier elements like gold, silver, and even uranium. Elements that couldn't be formed in the star's lifetime are now birthed in its dramatic death. Supernovae scatter these newly minted elements across the cosmos, seeding future stars, planets, and ultimately, life. In the fiery death of a massive star, the building blocks of life are forged. So, we've journeyed from the birth of a star to its dramatic end. But what are the key takeaways? Let's retrace our steps. Stars are born in the depths of nebulae, vast clouds of dust and gas. It's here that gravity weaves its magic, pulling matter together to form a protostar. With time, heat, and pressure, these protostars mature into main sequence stars, like our very own Sun. They spend the majority of their lives fusing hydrogen into helium, radiating energy and light. But eventually, the fuel runs out. Smaller stars fade into white dwarfs, while the massive ones explode in a supernova's fiery spectacle. But supernovae aren't just about destruction. They're cosmic forges, creating the heavier elements necessary for life. The iron in our blood, the calcium in our bones, they all come from the heart of stars. And so, in the life cycle of stars, we find the cosmic story of creation, existence, and rebirth. Thank you for joining us on this cosmic journey. We've traveled from the dense nebulae's heart, where stars are born, to the spectacular supernova's end, where they meet their fate. We've learned how these celestial bodies live, evolve, and eventually die, giving rise to new elements and life in the process. It's a story of creation, existence, and rebirth, a story that's still unfolding as we speak. We hope you've enjoyed this deep dive into the life cycle of stars, and it's inspired you to look up and wonder. But our journey doesn't end here. The cosmos is vast and filled with countless mysteries waiting to be unraveled. So we invite you to join us again as we continue our exploration of the universe. There's so much more to discover, so many more stories to tell. Until next time, remember to keep looking up, because the sky isn't just above us, it's a part of us. And who knows, the next time you gaze at the stars, you might see them in a completely different light. Until then, keep exploring, keep questioning, and keep marveling at the wonders of the cosmos.